We are looking at this question. Find the eigenvalues and eigenvectors of the matrix A. Step one, eigenvalues. Okay? And then to do that, it's going to be determinants of the matrix. Then the main diagonal minus what? This is the leading diagonal. So this one minus R, minus R, minus R. And the others values remain the same. So this will be minus this. This will be 1, 1, 1, minus R, 1, 1, 1, minus R, equal to what? Equal to 0. Okay? This one is used to calculate what? The eigenvalue. And that will form what we have here. Okay? So the determinant now of this matrix, that will be, I'm using the first row. This one here. Okay, and that will be this one here. Cover it vertical, cover it horizontal. So I have this, and then to remain this one, this, and this. Then the second element on the first row, cover it vertical down, horizontal. So that will be minus 1 into bracket, minus 1. This one cover, so I have 1, 1, 1, 1, then 1 minus this. You're wondering, how does this minus come here? Don't forget the cofactor sign. Okay, so when you're doing determinants, you do it in conjunction with the cofactors. Okay, so if you are evaluating along the first row, you have to multiply each element by this sign. Okay, and cofactor is continuous, minus, plus, minus, plus, minus, plus. So it depends on rules you are using. If you are using first row, you do it in conjunction with this sign. Second row in conjunction with this sign. Third row in conjunction with this sign. If it's first column, also in conjunction with that column. Then the third one plus the third one, the one here, cover it horizontal and vertical. So you have plus 1, determinant of 1, 1, 1, minus this, then this, all equal to 0. Okay, so that's what we have now. Then we now have minus R brackets, this one times this one, that's R square. You go this way, and then minus what? Minus this one, so minus 1. Then the second one, minus 1 into brackets. This one minus R times 1, that's minus R. Then this one times this one, that's minus 1. This one go this way, that's 1. We have 1 outside here, so 1 into brackets. This times this, that's 1. Then minus this one times this one, that's minus R, becoming plus here, equal to 0. So what can we do now? Here we have this will be difference of 2 squared, and that will be R minus 1 into bracket R plus 1. Here, take minus outside, and that will be minus times minus, that's plus 1 into brackets. The moment you take the minus outside, it's going to reverse it. It's going to reverse the sign. And that will be R. Here also plus what? Plus 1. Okay. Then here also we have 1 plus R equal to what? Equal to 0. Okay. So what we can do now, we can rewrite this one plus R as what? As R plus 1. It's the same thing. Okay. So R plus 1 is there. R plus 1 is there. Then R plus 1. R plus 1 is also here. So we can take it outside. Take it outside. Then we now have minus this into bracket R minus 1. We have this one remaining. Then here we have plus 1. Okay. Here also we have what? We have plus 1 equal to 0. Okay. Then we now have R plus 1 into brackets this one, begin to open the brackets. This one times this one, that's minus r squared plus what? Plus r, and then plus 2 equal to 0. So we now have r plus 1 into bracket. Take minus outside here. So this will become what? R squared. Okay. And then this one times minus, that's minus what? R minus 2 equal to 0. So we now have minus this, r plus 1 into brackets. Here, we can factorize this quadratic expression equal to 0. And if you do that, r will be here. The factors of 2 that can generate minus 1, minus 2, plus 1. Multiply both sides by minus, so you now have r plus 1, okay, into bracket r plus 1, and then r minus 2 equal to 0. So this implies this is equal to 0, and then r is equal to what? Minus 1 here. Or this one also is also equal to 0. So r is also what? R is also minus 1. This one also is also equal to 0. So r is what? R is 2. The eigenvalues are minus 1. That one is twice. Is repeated value, and what? And 2. So that's the eigenvalues. So the next thing to do now is to calculate the eigenvectors for the respective values of r1 and r2. Okay? I mean minus 1 and 2. To calculate eigenvectors using this expression, okay, for r equal to what? 2. So what this means is that what this expression means is very simple. Okay, your r is what? Your r is 2. So that means we're having a minus 2i. Don't forget, I've said in the beginning of this lecture that I is your identity matrix, okay, and your r is what? Eigenvalues. Okay, so it becomes this. Then this one is this is the eigenvectors, and that's what we are looking for. That is what we are looking for. Equal to what? 0. Okay, so what this expression means, what it implies is just come back to your the leading diagonal, and then begin to deduct 2 from the what? From the leading diagonal. This minus 2, this minus 2, this minus 2, and other values remain constant. Doesn't change. Okay. The matrix, this expression become minus 2, 1, 1, 1, minus 2, 1, 1, 1, minus 2. Then, since we are having 3 by 3 matrix, the component of these eigenvector will be u1, u2, and u3 equal to what? 0, 0, 0. Okay? Then the next thing to do now is to do the augmented matrix using the row operation. Augmented matrix. We now have minus 2, 0, 0, 0. So, and I've discussed about augmented matrix that when you are only combining this matrix with the equal value, so this will be omitted. Okay, so that's that. And when you are doing augmented matrix, a line must be put in between the matrix and the equal value. Okay, then the next thing to do is to do the row operation. Yeah, all we're trying to do here, you just want to have 0 here, is to have 0 here, 0 here, 0 here. Okay, and if possible, the whole third row can be zeros. Yeah, even the second row can also become zeros. Okay, so row 2 is equal to, this is 1 here. So if you want to make this one to be 2, so it's going to be 2 row 2. Then this is positive, this is plus positive, this is negative. So that will be what? Plus what? Plus row 1. That's that. Then row 3 also. Row 3 also will be, this is also 1 also, the same thing also. That will be 2 row 2, and then plus what? Row 1. Row 1 is a reference point. It's not changing. It's our reference, is our baseline. So we now have now, this will become 2. 2 plus this, that's 0. Here also, this is a minus 2 times 2, then plus what? Plus 1. That's what? Minus 3 here. Here also, this is 1 times 2, that's 2, then plus 1, that's 3. Then 0 times 2 plus this, that's this. Then the third row, times 2 here, that's 2. Okay, then plus what? 1 plus minus 2. That's what? 0 here. Here also times 2, that's 2. Then plus what? Plus 1, that's 3. Here also times 2, that's minus 4. And then plus what? Plus 1, that's minus 3. And then this one times 2 plus this, that's 0. So we can see now we have 0 here, we have 0 here. Okay, it's not every time you must achieve your HLL form. It's not every time. So that's what we have now. So what we can do now, we can use row 3 or row 2 to generate an expression, an equation. Okay. So don't forget, I've said many times that the first column is for U1, the second column are the coefficient of U2, the third column are the coefficient of U3. So using row what? Using the third row. So that will be 0 times U1, that one is 0, then 3 times U2, 3U2, then minus 3 times U3, minus 3 U3 equal to 0. 3 we cancel out. So U2 is equal to what? U. Then the first row will give us minus 2 U1, then plus U2, and then plus U3 equal to 0. Don't forget, this will be minus 2 times this one, 1 times U2, 1 times U3. So then we now have minus 2 U1, U2 is equal to U3. U2 is equal to U3 plus U3 equal to 0. So we have 2U1 minus this plus 2U3 equal to 0. Then we can move this one to the other side. So we have, okay, minus 2U1 equal to minus 2U3. So minus 2 we cancel. U1 is equal to U3. So what we just do is just consider what? Consider U3 to be what? To be this, to be X. Okay. So the eigenvector will now become U1, the components, U1, U2, U3. My U1 is what? My U1 is equal to U3. That's X. My U2 is also what? My U3 is also this. So I can factorize this one. So that will be equal to what? 1, 1, 1. So, okay. So we take this vector as what? As eigenvector for R equal to what? For R equal to 2. And that's that. Okay? We assume that this one is equal to what? Is equal to 1. Step 3 is to calculate using this expression. Where this symbol is what? Is a eigenvector. I mean, this one is eigenvector, and this one is the eigenvalue. So we can plug in the value of this, and that will be equal to what? A plus this, okay, equal to 0. And the meaning of that, is we are having plus 1 here now. We just come back to the leading diagonal, so this will be plus 1, plus 1, plus 1. And that's the meaning of this. This. You can also do it this way. The leading diagonal, that's 0, the first one here. Then, is minus R, minus 1. Okay? You can see now that become what? 1. But without wasting time, let's just go straight to this expression. Let's go straight to this expression, and that will be equal to the matrix. This one, the implications of this is the main diagonal plus 1. That's 1. While the other elements remain the same. So plus 1, plus 1. Then 1. Here also, leading diagonal plus 1. Okay, plus 1, plus 1, plus 1. Here also plus 1. Then you close the matrix. Then here, the component of this is what? U1, U2, U3. Equal to what? 0, 0, 0. The next thing to do is to get the augmented matrix. Get the augmented matrix. And that is the combination of this one and this one. So that will be 1, 1, 1, 1, 1, 1, 1, 1, 1, then 0, 0, 0. Okay. Then the next thing to do is to do the row operation. Okay. And that will be row 2 is equal to row 2 minus 1. And then row 3 also is also row 3 minus row 1. What we want to achieve is to have at least the second row, the first element, to be 0. Here also, the first element here to be 0. And that's our target. Okay? We now have row 1 is a reference point, 1, 1, 1. That's my reference point. Row 2, that's 1 minus 1, that's 0. Here also, 1 minus 1, that's 0. 1 minus 1, that's 0. So I have 0, 0 here. Then the third one, the same thing also, that'll be 0, 0, 0. Okay? We only have the non-zero is just the row 1. So row 1, we now have U1 plus U2 plus U3 equal to 0. And that gives us U1 is equal to what? Minus U2 minus what? U3. So therefore, let us consider U2 to be this, to be X, and U3 to be what? To be T. Okay? So in that case now, U1 is equal to what? Minus X minus T. The second eigenvector is now, U1 is what? Minus X minus T. U2 is what? U2 is X. We can segment it into 2 parts, and that will be equal to what? That will be equal to minus X, X and 0. And then plus what? The second one, that will be what? Minus T. This one, there is no T here, that's 0. This one, we have T here, that's what? That's T. So we have done the segmentation of that equation. Okay. Then what we can do now is to factorize the X here, and that will be minus 1, 1, 0. And also factorize the T, that will be minus 1, 0, 1. So we take this vector and this one as what? As eigenvector. As eigenvector for r equal to what? R equal to minus 1. And that is that on this question. If you're yet to subscribe, please smash that notification bell. There's a link on the video. Click on it and subscribe to this channel so that you can keep track of the updates of this channel. Okay? And then begin to type your comments. Let's make this section interactive. Begin to type your comments, forward your questions. Okay? And I'm going to respond to it as fast as possible. Okay? And also click on the like button across all our videos. Take the video viral. Thank you for doing that.